greatest common factor. You always have to find the greatest common factor, the largest term that divides everything in your expression. And, you know, we've done a bunch of these already, but if I give you something simple like 12m squared plus 3m to the sixth, what would be the greatest common factor? 3m squared. Good. So you're picking out a constant, which in this case is 3, and then you take the common variable with the lowest power that it appears. So in this case, it's 2. So if 3m squared is our greatest common factor, what is left? 4 plus m to the 4th. Okay, good. So just don't forget about the variable part as well. Okay. So what we're going to talk about today is our second factoring technique, is factoring by grouping. So every time you're starting with a factoring problem, if you're given something and the question is factor, the first thing you should always look for is for the greatest common factor. That's what you want to find first. If it's there, good, take it out, and then see what else you can factor. But if it's not there, oh well. So first thing, always take out the greatest common factor, if there is one. But now we're going to focus on cases that have 4 terms with no common factor. So here's an example. I'll just start you off with an example. 3x cubed minus x squared plus 18x minus 6. Okay? So first of all, is there a common factor among those 4 terms? 1. So no, right? But we can still kind of factor this thing by the technique that we call factoring by grouping. We're actually going to group this problem into 2 pieces. And if you just look at the first 2 terms, is there a common factor in the first 2 terms? X squared. So I'm just going to do that. So I'm going to take the greatest common factor out of the first 2 terms. So it seems like it's an x squared, and then this leaves us with what? 3x minus 1, right. So we need that placeholder, okay? So that's just factoring the first 2 terms. If I look at the next 2 terms, do they have a common factor? 6. So let's take that out. If I take 6 out, that leaves us with 3x minus 1. Right? What do you notice, if anything? Yeah, 3x minus 1. So that looks like some of the problems we did last week. When we were factoring expressions that had a common parenthesis, we had a smiley face in there or whatever. But we just have to realize that now we have 2 terms separated by a plus. And what's in common in those 2 terms is 3x minus 1. 3x minus 1 is the greatest common factor. Okay? So if I take out 3x minus 1, what is left? if I factor out 3x minus 1, x squared plus 6. Now that's it. Doesn't work every time. Not any, 4 terms can be split up like that. Sometimes you're given 4 terms in a mixed up order, so you have to reorder them in a way it factors nicely. But so far, questions on this example? You group it. First 2 terms, take out the common factor, and then you hope that you end up with the same parentheses. Keep that in mind. These parentheses have to match, and when they do match, you can factor that term out. How can I make sure that that's the right answer? What? What does that mean? Yeah, so if you do the FOIL, I should get the original problem back, right? So you don't have to do that, but you can always double check yourself. So if you go 3x times x squared, that's 3x cubed. 3x times 6 is 18x. Negative times x squared is negative x squared. And negative times 6 is negative 6. Is that the same as the original? It's only in slightly different order, but that's okay. Right? Let me show you something. Don't write this down. Let's say the problem was given to you in this order, and we try to factor by grouping again. Don't write this down. But if I just stick with the original plan, I'm going to look at the first 2 terms. What is the greatest common factor in the first 2 terms? It's 3x, right? So if I take 3x out, what is left? X squared plus 6, right? Now, in order for this thing to work, I need another x squared plus 6 to appear. So when I look at the negative x squared and negative 6, how can I turn it into positive x squared plus 6? Yeah, just take out negative 1. The common factor there is negative 1. I can just take out the negative, and that leaves me with x squared plus 6. Sure. Right? If you distribute it back, you still get the same thing. So I'm really taking out the negative 1. Well, now x squared plus 6 is the common factor. And if I take that out, that leaves me with 3x minus 1, which is, same. Right? So in this case, almost didn't. Well, the order almost doesn't matter. Sometimes it does. Sometimes you have to rearrange a little bit to make it work. Okay, so let's just do a bunch of these. How about y cubed minus y squared plus 3y minus 3? That shouldn't be too bad. Right? But again, first look for the common factor. And there is no common factor, right? Among all 4 terms. So then we should start grouping. So first 2, what do I take out? Y squared. So if I pull y squared out, what's left? Y minus 1. Very good. And now look at the last 2 terms. What should I pull out? 3, so positive 3. And that leaves us with y minus 1. Good. So you see, you're getting that y minus 1 again. I just realized I didn't give you a quiz. It's right there. So take out y minus 1, and that leaves us with what? All right. Let me give you your quiz. You should do good on it now, since of course, there's nothing like that on that quiz, but just basic factoring, taking very easy. How do you do the first one? What's the common factor? Just 6, right? And if you take 6 out, you should be left with x minus 2y. All right, good. Go to the next one. 3x squared, right? So again, you choose the lowest power. So 3x squared, and then start dividing everything by 3x squared. So you end up with 1 minus 2x squared plus 3x. You didn't do the 1? We just spent this whole about 1. Well, again, if you don't put 1 there and you try to distribute, you don't get the original problem back, right? If you don't have 1 and you distribute like that, you'll end up with just this 2 terms, so there's nothing gives you 3x squared. So you need that 1 to produce the 3x squared. And here, if you FOIL, x squared plus 5x minus 5x minus 25, so that's x squared, right? X squared minus 25. Yeah? Good. All right, back to factoring by grouping. Let's try this one. 3x to the 4th minus 3x cubed minus 15x squared plus 15x. So how would we go about this one? Out of the first two? Well, again, remember, you should always look for the common factor. That's the first thing. Is there a common factor in all 4? 3x, right? So first, we should pull out 3x. And that leaves us with x cubed minus x squared minus 5x plus 5. But that's always, we should do that first, because if there is a common factor, it will make the remaining problem a lot smaller and easier to deal with. Because you're still going to end up with a 3x factored out. Well, now, forget about that 3x for a second. Let's just focus on what's on the inside. Now we're going to proceed with factoring by grouping. So when we look at the first 2 terms, x cubed and x squared, so if we take x squared out, what is left? X minus 1, right? Now, in order for this to work, we need another x minus 1, right? So how do you turn negative 5x plus 5 into something times x minus 1? What should we factor out? Negative 5, because it feels like we need to switch the signs. So taking out negative 5 will do the trick then. Negative 5x becomes x, and positive 5 becomes negative 1. Right? Well, and then the rest, the common factor is x minus 1. We can take that out. And that leaves us with x squared minus 5. So here we go. So here's that big problem factored completely, gave us 3 terms there. Is that okay? questions on that? Does that make sense? This one? So we're just looking at these two terms, just looking at the greatest common factor, which is x squared, right? You always choose the lowest power. So if you take x squared out, you have to divide both terms by x squared. So x cubed divided by x squared is x, and negative x squared divided by x squared is -1. Is that all right? Hmm? Well, yeah, because it had that extra factor. Yeah, that's okay. Let's try this one. Maybe something similar. A cubed minus 3a squared minus 2a plus 6. So, what do we take out? Is there a common factor among all four terms? Always should check for that. And the answer is no, right? Because like the last one is a constant. So first two, what are we going to take out? A squared. So if we pull a squared out, what is left? A minus 3. And again, remember, you want another a minus 3. That's what you want. So what should you take out of the last two terms? -2. So that gives you a. And positive 6 will turn into -3. So both signs change. Okay, because you're taking the negative out. And again, if you just stick to that whole division thing, just divide both terms, your signs will be correct. And so then a minus 3 is the common factor. We'll take that one out. And it leaves you with a squared minus 2. How is that? Is that good? How about this? X squared plus ax plus bx plus ab. What do you think? What do you want to do here? Group it? X plus a plus b times x plus a. Very good. Right? And then x plus a times what? X plus b. Isn't that fun? Let's try something a little messier. bdy squared plusady plus bcy. What the hell is all that? Plus ac. Will we even be able to do that one? Yeah, well, yeah, sure, we can do that one. I removed that from the syllabus. I told you that, right? After I spoke with the sheriff. So So what do we do here? What's the common factor? Let's start grouping. dy. So if you pull dy out, what is left? by plus a. All right. Last two terms. C. So pull c out. What is left? by plus a. Right? Well, that worked out better than we thought. So by plus a is our common factor. Yep. So by plus a times dy plus c. Good? You like that? Okay. So that's basically factoring by grouping. So that's the second type of factoring. The third type, I'll introduce it today and we'll drive it home on Wednesday. So factoring trinomials of the form x squared plus bx plus c. So I'm talking about quadratic trinomials when there is no coefficient in front of the square. Because if there is a coefficient in front of the square, it's becoming a whole lot harder to do. But if there is no coefficient, we can actually do this with relative simplicity. Well, you just need to know a trick. So here's an example of what I'm talking about here. For example, x squared plus 4x minus 12. So here's a trinomial. It's a quadratic, power 2, and there is no coefficient in front of x squared. Now, notice how there is no greatest common factor, right? And I cannot factor by grouping, because there are only 3 terms. When we were factoring by grouping, we had 4 terms. Here's only 3, right? So right now, like, we're kind of stuck. Like, first of all, some of you probably know how to factor that. You know how to factor that? You know how to factor that? What? Well, right, this is what you want. You want to end up with something like that. Most likely just going to be x and x, right? We're trying to FOIL backwards. But here you're going to have, that's the question. Something like that. Yeah. So we're going to, right. So we're going to discover that a little bit. Because again, so what he's saying, like, can you think of 2 numbers that multiply to negative 12 and add to positive 4? 6 and minus 2, right? 6 and negative 2 multiply to negative 12. 6 and negative 2 add to 4. Okay? Now I'm going to write a step that you don't use, so don't write this down. So I'm actually going to rewrite this problem. Instead of writing 4x, I'll write 6x minus 2x. This is still 4x, right? So I'm rewriting this problem. I'm splitting the middle. Did I say not to write this down? So, because it will confuse us. You just need to see what I'm doing. Anyways, do whatever you want. So, those 2 numbers came from the product is negative 12, the sum is positive 4. Now, can I ask you to factor by grouping? Yeah, now I can do by grouping, right? Because there are 4 terms. So if I just look at the first 2, what can I take out? X. That leaves us with x plus 6. And how about the next 2? Only I'm going to take negative 2 because that gives me x plus 6, right? So now x plus 6 is the common factor, leaves us with x minus 2. So we still ended up with those two numbers, plus 6 and minus 2. So all those steps that I just took are really redundant in this case. So in the case when there is no coefficient in front of x squared, if you're able to find two numbers that multiply to the constant and add to one in the middle, then you just go, then you're done. There's nothing else to do. Okay? If I go back to this example right here, there's the reason why I put it there. If you multiply a and b, you'll get ab, right? And if you add a and b, you will get this number in the middle. Because if you combine like terms, you'll get a plus b, whatever those two numbers were, right? Do you see that? The sum of these two numbers, the sum of a and b, is the coefficient here, whatever a plus b is, right? Because this is a plus bx. So in order for us to factor this, we need two numbers that multiply to the constant and add to the number in the middle. That only works if there is no coefficient in front of x squared. So for example, x squared plus 5x plus 6. I'm looking for two numbers that multiply to positive 6 and add to positive 5. That should be pretty straightforward, isn't it? What two numbers multiply to 6 and add to 5? Both positive, right? Plus 2 plus 3. And we're done. Needed two numbers that multiply to 6 and add to 5. Is that okay? Oh, that doesn't matter. Yeah, that doesn't matter. How about x squared minus 5x plus 6? Two numbers that multiply to positive 6 and add to negative 5. Negative 2 and negative 3. We can always check by FOILing, but when in doubt. That's the nice thing about factoring. How about x squared plus x minus 6? I'm picking on 60. Two numbers that multiply to negative 6 and add to positive 1. So product is negative. What? Negative 2 and 3. If you add negative 2 and 3, you get positive 1. If you multiply them, you get negative 6. How about x squared plus 5x minus 6? Two numbers that multiply to negative 6 and add to positive 5. That, yeah. 6 and negative 1. X plus 6, x minus 1. Right? Because you can get 6 by multiplying 1 and 6, not just 2 and 3. Well, yeah, I mean, if I give you, that probably won't work, right? Because the only way you get 7 is 7 and 1, and there's no way you get 2 out of adding 7 and 1. So that one, that's a prime. That's a prime trinomial, cannot be factored, doesn't have any factors. Well, not necessarily, but you just have to try. And if it doesn't work, so this one is prime. But let me play with 6 some more, that's fun. How about x squared plus 7x plus 6? 6 and 1. X plus 6, X plus 1. So it does take a little bit of time to get used to this way of thinking, but it will happen. Yeah? How about x squared plus 12x plus 27? How would you split that one? Nine and 3. How about 2a squared minus 2a minus 24? So what are you all trying to do? I see the thinking process. Well, in order for me to put a on the outside, a has to be... Yes. You should pull 2 out first, because that's the first rule of factoring. Take out the common factor, because otherwise, whatever it is I'm teaching you won't even apply. I'm only talking about the case when there's no coefficient in front of the square term, while the problem that I gave you does have a coefficient in front of the square term. But it happened to be the common factor. So if I pull 2 out, I'm just looking at what's left. So that's easier. Product is negative 12, and the sum is negative 1. What's that? The product is negative 12, and the sum is negative 1. Negative 4 and 3. Good. With a 2 on the outside. Isn't that fun? Factoring is good for you. Okay, I'm going to